Hi everyone, welcome back to the QuantaLumin YouTube channel. We talk a lot about design on this channel, but what if I told you that one of the most powerful design systems on the planet is through letters and numbers, and it's useful every day. So today we're going to be talking about algebra. It can kind of seem a bit intimidating, but it's worth remembering that the principles of algebra are to keep it really simple. The word algebra comes from the Arabic, meaning reunion of broken parts. I think that's a really nice metaphor. It sounds a bit like kintsugi, which is the art of repairing broken pottery with gold, and it's a Japanese tradition, used to make broken parts seem more beautiful and a whole. The Babylonians used it to design buildings and plots of land. The Egyptians used it to restore field boundaries, literally reuniting broken parts. And visionaries like Diophantus started using symbols as placeholders. This was a huge leap in thinking. Instead of solving one specific problem, they created a reusable, scalable template for solving equations, solving infinite problems. They designed systems rather than specific use cases. So how does this ancient design system work? Let's look at the core principles. Think of it less like maths and more like learning the grammar of a new creative language. Okay, so we're going to have a look at a few examples of algebra. So let's start with some simple expanding brackets. The most important aspect of algebra is the variable. So the common thing that we tend to use is x, but it doesn't have to be x. It could be a square, it could be a triangle. The variable could literally be anything, but in terms of algebra we tend to use x because it's easy, it's a letter. Our goal is simply to simplify things. So if we're using lots of strange symbols and things, it starts to get quite messy and it's quite difficult to work with. So keeping it to letters simplifies. So we're simply using it so that we can organize like terms. So let's look at an example of that. So we're going to try simplifying. So 2 brackets 3x plus 5 close brackets plus 3 open brackets x minus 2. So we're going to expand the brackets first and then we're going to simplify. So let's try expanding this. I'm going to take a colour. So I'm going to times 2 by 3x and I'm going to get 6x. I'm then going to times 2 by 5, which is going to be 10. Now you'll see here that this has kind of made a bit of a shape, and this is a nice way that I like to remember this. It's starting to look a bit like an elephant trunk, you may realise, and this is how I learned it at school, and it stuck with me ever since because it just looks fun. It looks fun and it's a good and memorable way of remembering it. So now that I've made my elephant ears and my elephant trunk for this side, I'm going to take the other side. So I will do 2 times x, which is 3x, and then I will do 3 times minus 2. Well, mixed makes minus, so in this case it's going to be minus 6. Great, so then I can have my elephant on this side as well. I've got 2 lovely elephants. And we'll keep the plus here because this is plus 3. So now that I've expanded my brackets, I can go ahead and simplify. So let's take a different colour. So here we're simply combining like terms. So 6x plus 3x is going to be 9x. And then I've got 10, positive 10, minus 6. So mixed does make minus, but this is still going to make plus 4. So we've taken a really complicated idea here and we've simplified it using the principles of algebra. That is good design, and that is why algebra is so useful. Okay, so let's look at an example of graphing and maths, which really is just maths and art, the visual form of algebra. So let's take the example of y equals 9x plus 4. So with this problem, we're literally working out what the y-intercept is, where it intercepts with the y-axis. And this is how I remember. So this is the y-axis because the calligraphy of the y is going down just like it would on the axis. And so this one is x. So to work out this y-intercept, we need to know what x is. So let's just presume that x equals 0. So 9 times 0 equals 0. So 0 plus 4 equals 4. So we know that when x equals 0, y equals 4. So we can pop that on our graph. 1, 2, 3, 4. There we go. Now we can work out what y would be if x equals 1. So 9 times 1, as we know, is 9, and then 9 plus 4 is going to be 13. So we're going to go along the corridor and up the stairs all the way to 13. So we've got our 2 points. We only need 2 points to make a line on a graph. So we can then make a line and draw through both of these points. And there we go. The link between algebra and geometry was thanks to René Descartes, and it literally allows us to draw with equations. And that relates to anything: digital art, vector-based art. And Descartes formalized how we look at area and volume. Because if I have 2 points, here, well, if I have 2 points, I've got 2 points, right? And I can start to make a square. And then I can work out areas. And if I go into the third realm, which would be the z-axis, then I can work out volume. And it gives me quite a nice shape. So there we go. So when I was at school, I really struggled with maths. It was definitely my hardest subject, apart from science, but we'll get on to that's another video. I had good teachers and I was in a small class, so that was helpful. But when I was doing my GCSEs, maths was the thing that I absolutely spent the most time revising because I knew that I had to pass if I wanted to move on and do the creative subjects that I wanted to do. Before I went in for my maths exam, I literally had a bit of a breakdown, I'll be honest. I was so scared. I was so scared of failing. I didn't feel confident, and I did get through it, and I actually did quite well in the end. I really want to help the next generation of girls who possibly in the same situation that I was in. I don't want people to have that because I think it can be avoided, and maths shouldn't be feared. Maths and science is incredibly useful even if you don't go into a scientific career. It sets your formative education, and if you have a really strong foundation, you're going to be able to power through into any career, whether that is being a creative. And you'll find actually as a creative that some of the most interesting projects that you can work on are when you're actually at the intersection of fields. So is algebra useful today? Yes, actually an invaluable tool in our everyday lives. We might not realise it, but let's see how. Maybe you're into coding, you're into tech. You're going to be playing with variables all the time. Rather than writing thousands and hundreds of thousands of lines of code, instead, if you can create a code that has variables, that's going to save you a lot of time, and that uses the principles of algebra. If you're a designer and you're doing some 3D modelling, take Blender for example. It's actually a Python program, so that means that it's using formulas and variables to map your model. Say you're in fashion, you're designing a dress that lights up and it's got LED lights. That's going to be based on the input variables of the LEDs, so you're going to need to use a bit of algebra for that. Say you're doing some DIY, you need a new shelf. You're going to be using algebra to figure out how much wood you actually need. You're going to have to figure out the area. They are using the basics of algebra. Design and engineering essentially uses algebra all the time to make sure that designs don't collapse. Take a bridge, take a chair. If you're designing a chair, you're not going to want it to collapse, so you're going to need to figure out its weight distribution and to calculate load and stress. But I think on a wider level, algebra teaches us critical thinking. It teaches us to break big problems into much smaller and manageable chunks. I think that's the most valuable skill in any field, but especially a creative one. But algebra is simply a language of creativity and problem solving that's been built over millennia, so we know it works. It's the hidden design tool to everything, from architecture to apps. It's a tool that lets you build your ideas, and that's a skill that every single designer, artist, creative needs in their toolkit. If you're a creative person who's been intimidated by maths, I hope this maybe gives you a different perspective. It's not to be feared. Thank you so much for watching. I really hope you enjoyed this video. Make sure to like and subscribe, hit the bell notification below, and send us your questions. What maths topics do you want us to cover next? We'll see you soon.